Hey guys, this is going to be a super quick video just examining how to graph things in 3D space. That seems to be what we are most struggling with in Chapter 8. Before I do that, I want to rediscuss just two-dimensional space here for a second. If I ask you to graph the point -3, 2 in two-dimensional space, we all know that means we start at the origin, and then we go along the x-axis. In this case, it'll be to the left 3. And then from that point, we go up to the y-axis 2. So there's the point -3, 2 in two-dimensional space. Okay. Now, typically, we don't need to do all this little hop it over here, but that's just in our brains what is going on when we graph points. In three-dimensional space, so let me do the same x and y coordinates, -3, 2, except I'm going to add a z coordinate of -5. So the thing to remember about 3D space is that the axes are different. It's not like that you keep x and y and then you add the third one. Everything is a little bit changed in terms of direction. The horizontal axis is y, to the right is positive, to the left is negative. The vertical axis is z, again, up positive, down negative. And then the weird one is x, popping out at us. Toward the front left is positive, and then to the back is negative. Okay, so let's kind of do what we did in two-dimensional space up here in that first example, but in three-dimensional space. Again, when you graph a point, you start at the origin, and then you travel these lengths along those axes. So we're first going to travel -3 on the x-axis. So that means we're going to start here, and we're going to go 1, 2, 3. And then from that point, we travel +2 in the y direction. So it's kind of hard to estimate where that is, but let's just do our best. So maybe that'll be 2. And then from there, we move downward 5 along the z-axis. So I don't know where that might be. Let's estimate. 1, 2, 3, 4, 5. And this would be your final point. Now, the hard part about graphing in 3 dimensions is it's difficult it's a lot more difficult to estimate. Are you going the correct distances along each axis? So that's why the idea of a prism is going to be helpful. Okay, so that's the take that I'm going to do on the second example. I'm going to graph the same exact point, -3 to -5, except I'm going to try to draw a three-dimensional figure so that we get a more accurate location for that point. So along the x-axis, I'm going to graph a point at -3. Then on the y-axis, I'm going to graph a point at 2. And then what I want you to do is I want you to create the parallelogram that would exist with these 2 points as 2 of the corners. So notice this blue parallelogram is going to end up being the top of our prism. Because, so, again, that's if we travel down the x-axis 3, over on the y-axis 2. So now we're at this top right corner point, but from there we have to go down 5, and that's what gets really, really arbitrary. So to help us with that, what we're going to do is on the z-axis, we're actually going to graph a point at -5. And then your job is to create a three-dimensional shape between this parallelogram as the top face and this point down here as, just a part of the bottom. So what we can do is, in order to draw that three-dimensional shape, let's create a rectangle between the z and the y-axis. And then we are going to create, this might be the toughest part, this parallelogram between the x and the z-axis. So these red segments are 2 parts, and again, you want to create the parallelogram that would finish that picture. So this one will come straight down, and then perhaps here. So now you have a three-dimensional shape, and let's again go back to the beginning and let's talk about travel. If I start, let me pick green. If I start at the origin, we travel. Again, I'm following the point -3 to -5. So it's going to be 3 down the x-axis, 2 to the right along the y-axis, and then from that point 5 down along the z-axis. and that ending point is your coordinate -3 to -5. Okay, that's how to graph a point in 3D space. To graph the vector in 3D space, it's the same exact logic, except your answer is a vector instead of a point. Okay, so let's this time graph the vector. Let's do 3, -1, 4. 3, -1, 4. Okay, so again, let's kind of do the prism outlook. So along the x-axis, this time is a +3, so it's going to be coming out at us 3, 1, 2, 3. Along the y-axis, it's going to be to the left 1. So this is going to be a very skinny parallelogram, right? Between these 2 points, between the x and the y-axis, I want to finish the parallelogram. So it's going to look something like this. And then on the z-axis, I'm going up 4. So that'll be this point here. So then again, your job is to create a prism between this parallelogram and that point. So again, this will be the bottom face now because we're on the positive z-axis. So you're trying to create this bottom face and you're going to draw some vertical segments, and this one horizontal, to start recreating that face. And again, you kind of have to let your brain adjust to the idea. And then once you have these 2 rectangles, or parallelograms rather, you want to recreate or finish the parallelogram among these. So this will be a vertical line, like so. And then you can connect those. So then again, go to the origin, and let's follow the numbers. 3 along the x-axis gets us here. -1 along the y-axis gets us here. And then up 4 on the z-axis gets us here. So this is the terminal point. This is the terminal point. And then if I erase this one here, so then if I erase everything else that I've just done to get to this point, I'll be able to see my answer a lot clearer. The answer is going to be the vector from the origin to that point in space. Okay, so that's actually the vector, and I'm just now realizing I made a big mistake in my notation that I originally gave you. What was this, 3? I don't remember the number now. Yeah, 3. Remember, vectors have the little sideways carrots instead of the points. So that's the difference between the vector and the points. So I hope this short video helps you visualize those prisms in space and know that, we weren't far off. Like if you compare these 2 points and where the actual point is, this one may have just been a little bit higher. So the prism helps you get a more precise example. And then of course the vector, you can leave the prism there. I just erased it so you could see what it is. But after you draw your prism, as long as you draw the vector to your terminal point, you're good to go.